All right, we're going to be solving this system of equations by the Gauss-Jordan elimination method. And so the pattern is make in row 1, column 1, A1, and then everything else in column 1, so that'd be row 2, column 1, and row 3, column 1. We're going to make those zeros. Then we're going to come and we're going to make row 2, column 2 a 1, and everything else in that second column 0. And then finally, row 3, column 3 will make that a 1, and then everything else in column 3 we're going to make this 0. This is Gauss-Jordan elimination, and so sometimes, we mentioned the diagonal of 1s there, or we have a lower triangle of zeros, and we also have an upper triangle of zeros. If you're just doing Gaussian elimination, you're just going to make the diagonal 1s and then zeros underneath. Full Gauss-Jordan elimination would make the zeros in the top and in the bottom there with the diagonal 1s. So first thing we're going to do is we're just going to write this as an augmented matrix. You can use kind of the parentheses notation or the brackets, doesn't matter. And first equation is negative 10, 10, 4, and 6. So I'm dropping the variables. So the column that you're in is going to dictate what variable you are. And then we have the augmentation line there for the equals. Second equation is 2 minus 4 minus 2, negative 14. And the third equation is negative 2, 2, 2, and 6, okay? All right, so the first order of business is we need to make the negative 10 a 1. So you're going to divide by negative 10. So we're going to do row 1, and we're going to divide that by negative 10. That's going to become our new row 1. Now, formally, that's negative 1/10. Row 1 replaces row 1, okay? So we're going to divide everything in row 1 by negative 10. So negative 10 divided by negative 10 is 1. 10 divided by negative 10 is negative 1. 4 divided by negative 10 is negative 0.4. And 6 divided by 10 is negative 0.6. Okay, so just take each one of those entries in the top row and divide it by negative 10. Okay, the second equation, the second row, and the third row are unaffected, so we will leave them as they are. Okay, then we'll go ahead and just for the sake of space here, we're just going to bring this on down. Okay, so we have completed the first step in the Gauss-Jordan elimination. From here, we'll take out the second and third columns in row 1 there. We'll make those zeros, okay? And so we're going to use the opposite of whatever numbers they are, 2 and minus 2 respectively, and they appear in column 1, so we're going to use row 1. Okay, so the opposite of 2 is negative 2, so we're going to do negative 2, row 1. We're going to add that to row 2, and that's going to become our new row 2. Now, when we do these row operations, we are using row 1, but row 1 is not being replaced. It's row 2, and then afterwards we'll also replace row 3. All right, so negative 2, row 1, added to row 2, and that's going to replace row 2. Okay, so we're going to take negative 2, and we're going to multiply it by 1, minus 1, negative 0.4, and negative 0.6. So negative 2 times 1 is negative 2. Negative 2 times negative 1 is positive 2. Negative 0.4 times negative 2 is 0.8. And negative 2 times negative 0.6 is 1.2. Row 2 is 2 minus 4 minus 2 and minus 14. Okay. So now add those. Negative 2 plus 2 is 0. 2 plus negative 4 is negative 2. 0.8 plus negative 2 is negative 1.2. And 1.2 plus negative 14 would be negative 12.8. So our new row 2 is 0, minus 2, negative 1.2, negative 12.8. Okay, so we've completed the second step in Gauss-Jordan elimination. Now we're going to make a 2. I'm sorry, no, we're not going to make a 2. We're going to make a 0 in row 3, column 1. So it's column 1, so we're going to use row 1. The opposite of minus 2 is positive 2, so we're going to do 2 row 1 plus row 3, and that's going to replace row 3. So 2 row 1 plus row 3, and that's going to replace row 3. Okay. All right, so we're going to multiply 1 minus 1, minus 0.4, and negative 0.6 by 2. So 2 times 1 is 2. 2 times negative 1 is negative 2. 2 times negative 0.4 is negative 0.8. And 2 times negative 0.6 is negative 1.2. Row 3 is negative 2, 2, 2, and 6. Now we're going to add. 2 plus negative 2 is 0. Negative 2 plus 2 is 0. Negative 0.8 plus 2 is 1.2. Negative 1.6 plus, negative 1.2 plus 6 is 4.8. And so we get something for free here. We get this extra 0 there, so that's good for us. Okay, so we got a 0 here, and we got a 0 for free. Okay, so that's good. All right. Let me go ahead and just rewrite my matrix real quick here, just so we have some room. Oops, I don't want to do this. I would just want to copy it. We could convert it to math, but that doesn't always work nicely. Okay. So the next thing we're going to pick on is we need to pick on negative 2. We wanted to make that a 1. Okay, so we're going to divide by negative 2. Okay. All right, so we are going to divide row 2 by negative 2, and that's going to replace row 2. Now, the formal way is minus 1/2. Row 2 replaces row 2. All right, so row 1 is going to stay as row 1, and row 3 is going to stay as row 3. Okay, so we're not doing anything to those 2 rows at this point in time. All right, so we're going to divide everything in row 2 by negative 2. So 0 divided by negative 2 is 0. Negative 2 divided by negative 2 is 1. A negative 1.2 divided by 2 would be just 0.6. And negative 12.8 divided by negative 2 would be 6.4. Okay, 6.4. All right, so we're almost done with that that first column. Sorry, not the second column. So we need to make a 0 up here. Okay, so we need to make this negative 1. We need to make that a 0. Okay, that's in column 2. So we're going to use row 2. Column 2, use row 2. The opposite of minus 1 is 1. Okay. All right, so let me go ahead and copy my matrix again. We're just going to bring it on down here. Okay. And our row operation is going to be 1 row 2 plus row 1, and we're going to replace row 1. Okay. So when we do this, we are using row 1, but we are using row 2, but row 2 will stay as row 2. And row 1 is going to, row 3, if I can talk today, row 3 is going to stay as put, or stay as is. Okay, so 1 row 2 plus row 1 replaces row 1. Okay, so row 2 times 1 is just going to be 0, 1, 0.6, 6.4. Row 1 is 1 minus 1, negative 0.4, negative 0.6. 0 plus 1 is 1. 1 plus negative 1 is 0. 0.6 plus negative 0.4 is 0.2. And 6.4 plus negative 0.6 would be 5.8. So new row 1 is 1, 0, 0.2, and 5.8. Okay. So we're 2/3 of the way there. We've now made a 0 in row 1, column 2, and we got for free earlier row 3, column 2 as a 0. Okay, so the next thing we need to do is we need to make a 1 in row 3, column 3. So if you're going to make a 1, you're going to divide by whatever the number is right now, and that number right now is 1.2. So we'll go ahead and do that. So we're going to do row 3 divided by 1.2, and that's going to be our new row 3. Now, the real way is 1 over 1.2. Row 3 replaces row 3, okay? When we do this row operation, row 1 and row 2 are unaffected. Okay, row 3, 0 divided by 1.2 is 0. 0 divided by 1.2 is 0. 1.2 divided by 1.2 is 1. 4.8 divided by 1.2 is 4, okay? Now, if you were going the back substitution route, this is z equals 4, and then y plus 0.6z equals 6.4. So you take z equals 4, that you plug that in there, and that'd give you the y. So then you get the y, and the last equation is x plus 0y plus 2z is equal to 5.8. So then you take your z, and you'd plug it in here, and then whatever your y is, you plug it in there, and that would give you the x. And that's the back substitution. That's what we use for Gaussian elimination. Since we're going to do Guass-Jordan, we're going to go a little bit further here. So we got the 1 here where we want that, okay? So last thing to do is to make zeros here. That's in row 3, columns 1 and 2. So if you're in column 3, you want to use row 3, okay? All right, so let me just go ahead and copy this down to the next page. All right, here we are. All right, so the opposite 0.6 is negative 0.6. So negative 0.6, we're going to use row 3. We're going to add that to row 2. That's going to replace row 2. And we're going to be using row 3, but we're not replacing row 3. Row 3 is done, okay? All right, so negative 0.6, row 3 added to row 2, and that's going to become our new row 2. Okay, so negative 0.6 times 0 is 0. Negative 0.6 times 0 is 0. Negative 0.6 times 1 is negative 0.6. Negative 0.6 times 4 would be negative 2.4. Okay. Row 2 is 0, 1, 0.6, and 6.4. So we add 0 plus 0 is 0. 0 plus 1 is 1. Negative 0.6 plus 0.6 is 0. Negative 2.4 plus 6.4 is going to be 4. So it's going to give us 0, 1, 0, and 4. Okay. All right, then we got one more step to do. The opposite of negative 0.2, sorry, the opposite, I gave you the result. The opposite of 0.2 is negative 0.2, all right? So negative 0.2, we're going to use row 3, and we're going to add that to row 1, and that's going to become our new row 1, all right? So negative 0.2, row 3, we're going to add that to row 1, and that's going to become our new row 1. Okay, so negative 0.2 times row 3, so we're going to multiply that by 0, 0, 1, and 4. Okay, so negative 0.2 times 0 is 0. Negative 0.2 times 0 is 0. Negative 0.2 times 1 is negative 0.2. And negative 0.2 times 4 is negative 0.8. Row 1 is 1, 0, 0.2, and 5.8. And so we'll go ahead and add them. 0 plus 1 is 1. 0 plus 0 is 0. Negative 0.2 plus 0.2 is 0, and negative 0.8 plus 5.8 is 5, so it gives us 1, 0, 0, 5. Okay, so this gives us z equals 4, y equals 4, and not z, x equals 5. So then our solution would be the ordered triplet 5, 4, 4. Okay. All right, and then you can go back and you can plug in 5, 4, 4 into all three of the equations that will satisfy that. All righty, well, I hope you found this helpful, and we'll see you next time.